Hello everyone, welcome back. This is 1-12, Configuration of Piston Layout in the Combat Redstone series. I'm Immune2022, and as the title suggests, today we'll just look at some techniques and concepts that you would need to know when configuring piston layouts. And this will be a rather short chapter, but then without further ado, let's dive into it. So before we configure any piston layouts, we need to know what piston layouts are. So where's a piston layout? A piston layout refers to a set of sticky pistons or pistons that can open or close the door by powering the pistons in a specific order. Now, in addition to the piston layout, we also have another thing called a powering layout, which refers to the additional wiring to the piston layout such that the combined layout, so both layouts combined, can open or close a piston door by powering the layout in a specific order. Now, for simple doors, you actually don't have to consider the powering layout because it should be rather simple. So considering that isn't that useful, to be honest. So we are not going to really discuss it in this video. So we'll just discuss on piston layouts mainly. Now, the most important thing about a piston layout is that it has to be working and or functional. Because if you have a piston layout that doesn't work, then you cannot even open or close the door. So it just has to work at least. So we can check this by powering the pistons with redstone block or using zero ticking tricks from 1.16 that we have. So for example, you can have this here. So you can either do this with a redstone block, so you can extend the block, or you can just do a lever or button zero ticking. So yeah, both of these work. So you can just use either of these methods to check if a piston layout works by powering the pistons in a order such that the pistons can put the blocks into the door position and out of it and back to the initial position. So yeah, that's basically how you would check if a piston layout is working or not. So a good piston layout should be easy to wire and at least relative to other possible piston layouts. So how would you make your piston layouts be easy to wire then? Well, this requires some fundamental concepts of creating piston layouts. So I'm going to introduce two of the basic ones here, although there are also some more complex ones that I won't be discussing in this video, but in another video. So yeah, the first one would be the minimum piston extender length principle. Yep, it's quite a long name. So what this principle suggests is that we should always minimize the length of piston extender used. So what do I mean? Well, imagine a door. You can retract the door block with a single piston extender or a double piston extender. What would you choose? You should choose a single piston extender, right? Because a single piston extender would be simpler than a double piston extender. So another example would be if you can choose to retract a door block with a double piston extender or a triple piston extender, which one should you choose? Of course, the double piston extender, because it's going to be simpler than the triple piston extender, right? And it's also more compact, to be honest. So that's the concept entailed within this principle, is that you should pick the piston extender with the minimum length, because this will make your life easier in wiring it, and also you will basically ensure a more compact size, at least in the introductory level. This principle is not always strictly followed because of some volume considerations. So this is out of scope of the introductory level. And you can always refer to 2-11 methods of compacting for further discussion. And yeah. So yeah, that's basically the principle. And I will just illustrate you with this example that I will later introduce to you. And the next concept would be the concept of storage. So when there are multiple blocks that needed to be retracted from the same side, we can move the blocks to the side to allow the extender to pull another block. And the block moved to the side is also known as a storage block, and the piston that moves the storage block would also be called a storage piston. So yeah. And a common example which you should have learned from a previous video is the 1x2 semi-hipster door. This is by Melon BP, but then it's just to illustrate the concept of storage here. So we can just see it in action if you haven't seen it. Okay, so where is the concept of storage? Well, it's basically this block. Now, see, we need to retract both of these blocks with the same extender. So how would we do it? We need to retract this first block, of course, and then we need to move it to the side to allow the double piston extender to fire, grab the block, and retract the block. So that is the concept of storage. Basically, it just means that you need to have a storage piston that pulls the block away from the extender, such that the extender can push again to retract the block further. That's basically that. So yeah, should be quite simple to understand, I think. But then these are the two fundamental concepts that you need to know when creating piston layout. So creating a piston layout should be easy, but then some fundamental concepts that people might miss are these two. So yeah, now I will just illustrate you the first principle, which is the minimum piston extender length principle to you by using this 3x3 seamless cave door. So there are 9 door blocks as you can see here, and you can see that 8 of these 9 blocks, which are all of these at the side except the center block, they all are touching at least one of the sides. So what does this mean? You can always use a single piston extender to retract these 8 blocks. And yeah, so you do not want to use a double piston extender to, for example, retract this block right here, because you just overcomplicate things. You shouldn't do that. At least in the introductory level, you shouldn't do that, because instead of using a double piston extender here, you can always just use a single piston extender here, right? So yeah, that's basically what the minimum piston length extender principle entails. Just use a single piston extender, because why would you need a double piston extender when you can just use a single piston extender? So yeah, also when you have made a piston that can retract a block, you can just delete the block. That is easier for you to remember which blocks you have already dealt with. So yeah, so for these 3 blocks, I can just use these 3 side pistons, for example, to pull it from the side. So same for these 3. So yeah, you can see I remove all of those 3 blocks because we have already dealt with them. So yeah, again, remove these 3 blocks, and then the final one, we can just do it from the top. So yeah, all of these 8 blocks can be achieved by using single piston extenders, so we should use single piston extenders. And then now the center block. Well, unfortunately, it's not touching to any of the sides. And no matter which side you decide to pull it from, you always need a double piston extender. So yeah, we have to use a double piston extender. And pulling from any of the sides is actually fine. So yeah, here's an example. I will just pull it from the top. You can always pull it from the sides or the bottom. I don't really care. But then as long as you use the minimum length of piston extender, that's fine. So yeah, that's basically that. And that is already all of the knowledge that I have to show you. So I will just go on and mention some of the exercises. Now, the first one would be asking you to create a 4x4 seamless cave door piston layout. By seamless, this means that all of these quartz blocks here, you cannot move them. It has to be intact. Well, not you cannot move them, but you cannot change them. So yeah, there's a volume restriction, which is 200 blocks. So this basically means that you can work out your piston layouts from extending 2 from each side. So the top, bottom, and 2 sides. So yeah, all of these 4 sides, you can just extend 2 blocks. So yeah, just use the minimum piston extender length principle. And yeah, there are also a lot of solutions to this. So yeah, If you follow the principle, then you're basically correct. So no absolute answer here. The second one would be this here. This is called a full hipster, a 2x2 full hipster door. So yeah, basically just create a layout for this. And this basically just tests you on whether you can apply the concept of storage. Because for a full hipster door, you have to have these quartz blocks that cannot be changed. So you cannot use pistons right here. So yeah, you cannot do this. This is not allowed. So you need to think how you can fit the stored pistons, the storage pistons and the stored blocks. You need to think of how you can do that, and also how would this change the main piston extender. So yeah, you just need to think of this. That's basically the purpose of this exercise. And the third one would be these two. You don't even have to work for any piston layouts, because the question literally just asks you to verify that these two piston layouts are working piston layouts for 2x2 seamless glass door. So yeah, so remember when I said you can verify a piston layout by just using redstone blocks and lever 0 ticking. So yeah, just develop a way such that you can power these pistons in a specific order such that it closes and opens the door. So that's how you verify it. So there are no solutions to this. You just need to know the process of doing it. So yeah, that's basically it. So if there are no additional videos after these 12 chapters, this should in fact be the last chapter I have in the introductory series. However, there will also be 2 more videos, or at least 2 more chapters. One is a 3x3 piston door guide, and another one would be an assessment for you. That is for you to create your own piston doors and also some related builds. So yeah, those would be the last 2 chapters in the introductory series. So thank you all for supporting this series throughout, and if you want to learn more advanced or complex topics, then you can head on to the intermediate or advanced level, although I would suggest you to check out the intermediate level first. So yeah, thank you all, and I will see you in the next video.